Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 8 of International A-Level Edexcel M1 January 2022 paper. Alright, so the question says that a ship A moves with constant velocity 3I minus 10j kilometer per hour. At time t hours, the position vector of ship A is r kilometer. At time t is equal to 0, ship A is at the point with the position vector 13I plus 5j kilometer. So the requirement of part A is to find r in terms of t. So what we need to do, we need to find the position vector of ship A in terms of t. Since the position vector of ship A is r, so we need to find the position vector of ship A, meaning RA, it will be equals to R naught plus V times t, where Vt is basically the displacement vector. So in place of displacement, we are going to write Vt. So as we know the fact that when time t is equal to 0, the position vector of ship A is 13I plus 5j kilometers. So we are going to say that R naught is equals to 13I plus 5j. And the velocity vector is given to us in the question, which is 3I minus 10j kilometer per hour. So therefore RA will be equals to 13I plus 5j plus the velocity vector multiplied by t, and the velocity vector is 3I minus 10j. So it will be multiplied by t. So the answer of part A is therefore 13I plus 5j plus t times 3I minus 10j. So this is the answer of part A. And then before part B, we have some information that another ship B moves with constant velocity 15I plus 14j kilometer per hour. At time t is equal to 0, B is at the point with the position vector 3I minus 5j kilometer. So the requirement of part B is to show that at time t hours, the AB vector is 12t minus 10 into I plus 24t minus 10 into j kilometer. We need to show this. So here I'm going to solve part B. And since we know the fact that for ship B, when time t is equal to 0, the position vector is 3I minus 5j kilometer. So therefore R naught will be equals to 3I minus 5j. And then as we know that the constant velocity is 15I plus 14j kilometer per hour. So the V vector is 15I plus 14j. Okay, so we are going to make the equation for the position vector of ship B, which will be equals to R naught plus V times T. So therefore, the position vector for ship B is equals to 3I minus 5j plus 15I plus 14j into T. So what we need to do, we need to show the vector of AB. All right. So RB is basically the position vector of ship B at point T. So therefore, this is the OB vector, and the answer of part A, which was the position vector of ship A, we can say that this is the OA vector. And therefore, we need to find the AB vector. So we are going to use the subtraction law of vectors. So therefore, AB is equals to OB minus OA. So now what we are going to do, we are going to find the expanded form of the OB vector and OA vector respectively. So for OB vector, I can say that this is equals to 3 minus 5 plus t times 15, 14. So basically I'm using the column vector form. So OB is equals to 3 plus 15t, and the j component is 14t minus 5. And in this way, I'm going to find the OA vector as well. So for OA vector, I'm doing the working over here. So OA is equals to 13, 5 plus t times 3 minus 10. All right. So I can say that the OA vector is equals to 13 plus 3t, and the j component is 5 minus 10t. So now what we are going to do, we are going to find the AB vector. which is OB minus OA according to the vector subtraction law. So I'm doing the working with black pen. So AB is equals to OB vector minus OA vector. OB is 3 plus 15t, 14t minus 5, and then we will subtract the OA vector from it, and OA vector is 13 plus 3t, 5 minus 10t. All right. So therefore, we can say that AB vector is equals to 3 plus 15t minus 13 minus 3t, and the j component is 14t minus 5 minus 5 plus 10t. So I'm continuing the working at the top. So therefore, AB vector is equals to 12t minus 10. Okay, the I component is 12t minus 10, and the j component would be 24t minus 10. So therefore we can say that AB vector is equals to, since the I component is 12t minus 10, so 12t minus 10 completely multiplied by I. Since the j component is 24t minus 10, so plus 24t minus 10 completely multiplied by j. And then we will mention kilometer as well. So this is the answer of part B. All right, so after that we have part C. It is said that given that the two ships do not change course, the requirement of part C is to find the shortest distance between the two ships. So I'm going to do the part C and D on the next page. All right, and here we are going to solve part C. So we need to find the shortest distance between the two ships. All right. So as we know the fact that the distance between these two ships would be the magnitude of the vector AB. All right. So first of all, we are going to find the magnitude of the vector AB in terms of t. And since we know the fact that AB vector is 12t minus 10 into I plus 24t minus 10 into j. All right. So in order to find the magnitude of the AB vector, square root of 12t minus 10 whole squared plus 24t minus 10 whole squared. So we can say that the expression for the distance between A and B is under root of 12t minus 10 whole squared plus 24t minus 10 whole squared. All right. So first of all, what we are going to do, we are going to remove this square root, and for that purpose, we have to take whole square on both sides. Okay. So therefore, I can say that d square is equals to 12t minus 10 whole squared plus 24t minus 10 whole squared. So here the concept is that basically, since we want to find the shortest distance, we need to find the least value of the distance, and we can do it in multiple ways. Either we can do by completing a square form. First of all, we will expand this equation, okay, and then we will convert it into a completing square form so that we can identify the turning point of the quadratic graph. All right, so the graph of d square against t. And the alternative way is to apply the concept of differentiation. All right, so first of all, I'm going to expand this. D square is equals to 12t whole squared minus 2 times 12t times 10 plus 10 squared plus 24t whole squared minus 2 times 24t times 10 plus 10 square. Okay. So therefore, I can say that the expanded form d square is equals to 144t square minus 240t plus 100 plus 576t square minus 480t plus 100. All right. And then we are going to simplify the terms. So therefore, d square will be equals to, so 144t square plus 576, this is 720. So 720t square, and then minus 720t plus 200. So first of all, we have obtained an equation for d square. So basically here we have a quadratic graph. on the vertical axis you would be having d square, and on the horizontal axis you would be having t, and we need to find the least value of the distance. So as we want to find the least value of the distance, the shortest distance between the two shapes, so the shortest distance will occur at this value of t. And first we need to find this value of t. So in order to find this t value, you can convert the general form of the quadratic equation into a completing square form, or alternatively what you can do is apply the differentiation method. So therefore we are going to differentiate d square with respect to t. This will be 720 times 2 multiplied by t raised to the power 2 minus 1 minus 720 and then plus 0. So therefore 720 multiplied by 2 is 1440. So therefore we can say that when we differentiate d square with respect to t, we get 1440 times t minus 720. So what we are going to do, we are going to equate this expression with 0. So 1440 t minus 720 will be equal to 0, and therefore we will find the value of t at which the least distance, at which the shortest distance will occur. So therefore t is equal to 720 divided by 1440. So therefore t is equal to 0.5. This value of t is 0.5, and we need to find the corresponding value of d square. So we are going to substitute t is equals to 0.5 back into the equation. So d square will be equals to 720 times 0.5 square minus 720 times 0.5 plus 200. So 720 times 0.5 square minus 720 times 0.5 and then plus 200. So d square is basically 20. So the least value of d square is 20. So therefore, as we want to find the least value of the distance, so d will be equals to plus minus under root of 20. And since you know the fact that distance is a scalar quantity, it is always positive. So therefore, we are going to say that d is equals to under root 20 kilometer. All right. Either you can mention this exact value or you can write correct to three significant figures. D is equals to 4.47 kilometer. All right. So this is the answer of part C. So now in part D, we need to find the bearing of the ship B from ship A when the ships are closest. So now as we know the fact that the ships are closest when t is equals to 0.5. All right, t is equals to 0.5 hours. So what we are going to do first, we are going to find the vector of AB. So I'm going to erase the working of part C so that we can solve part D on the same page. And as we know the fact that when t is equals to 0.5, the ships are closest. They have the shortest distance between them. So when t is equals to 0.5, so AB vector is equals to 12 times 0.5 minus 10. This is the I component, and the J component would be 24 times 0.5 minus 10. 6 minus 10, this is minus 4. So AB vector is equals to minus 4I plus 2J. AB vector is minus 4I plus 2J. So now what we are going to do, we are going to visualize this situation. For example, here you have ship A at this point. So from A till B, horizontally, you are going minus 4. Okay, so towards left, this will be minus 4i. And then you are going vertically upwards 2 units. So this is 2j. So at this point, we have ship B. Okay, so here we have the AB vector. So now what we need to do, we need to find the bearing of ship B from ship A. So on ship A, I'm going to make a north. And since we want to find the bearing, so we are going to find this complete angle. All right. So obviously you would need this angle, which I am marking with green pen. Let's say this angle is known as theta, this green angle. So we will find this angle theta, which will be tan theta is equals to opposite over adjacent. So 2 divided by 4. So therefore theta will be equals to tan inverse 2 over 4. So tan inverse 2 over 4, this is supposed to be how much? 26.565 degrees. All right. This acute angle is this green angle which I have marked. The acute angle is 26.565 degrees, and therefore the bearing would be 270 plus 26.565 degrees. All right. So 270 plus 26.565. This is 296.565, and therefore we will mention this as three significant figure value 297 degrees. So therefore the bearing of B from A, ship B from ship A is 297 degrees. So this is the answer of part D. This was the question number 8 of International A-Level Edexcel M1 January 2022 paper.